Morning, grade 12 physics. At least it's morning for me doing this right now, like 8:45 in the morning. So we have our next little video talking about velocity versus time graph. So you probably already watched the distance versus time graph. Now we're going to look at a velocity versus time graph and kind of what kind of graphical analysis comes with that. So let's, this is going to be right out of your practice questions. We have practice question number 6 that I'm going to kind of be looking at mostly to start off with. So yeah, so we have again a velocity versus time graph. And so let's go through question 6 and 7, okay? Question 6 is the longest part, and then it'll kind of get easier from there. So it says, what is the displacement of the object over the 50 seconds? So basically over the whole time. So this is just talking velocity. Basically you have a 4 meters per second for a while. You have an increase in velocity. So anytime you're changing velocity, there's an acceleration. So on a distance versus time graph, basically to get acceleration, you have to have a curve. On a velocity versus time graph, anytime there's a change, there's going to be an acceleration, either positively or negatively. Okay, this is still an acceleration. It's just a negative acceleration over here. But basically our acceleration, our velocity is changing. But we're trying to find distance, like displacement is how far it went. So basically we're looking for, again, how much distance did they travel total. So let's try to kind of go over this. And there's 2 ways to do this. There's what's called like the graphical area way, where you look at the area under the graph. And then there's our formula way, okay? And I'll put a couple of our formulas, the ones that we're possibly using today. So we're using this one here, distance equals, in brackets, VI plus VF over 2, also by time. And eventually we'll be using this one here, acceleration equals VF minus VI over T. So I'm going to show both ways. Here is, again, the way that the way that I do it is I usually use the formula way, but I will show both ways, the area under the graph as well. So what that means is you want to break this into nice little like shapes. So I have a nice triangle right there. I'm going to put another little triangle here, and then I have a big box here that I can kind of do in red. So the nice thing is with the velocity and time graph, when you're finding the area of certain shapes, it'll tell you the distance, okay? So I have a nice box here, and to find the area of a box or rectangle, just go base times height. So I have 4, okay, times, and then 30, went from 0 to 30, so 4 times 30. So if I go 4 times 30, that's 120 meters. So I went 120 meters in this box. All right, if I do this triangle up here, I go base times height divided by 2. So if I go base, what's my base? It was 10. Again, don't go 30. This little line is 10. And my change here is 2. So what's 10 times 2? 20 divided by 2, so I get 10 here. So I get another 10 meters here. Lastly, big triangle here, base times height divided by 2. My base is 20. My height is 6. So we'll go base times height, 20 times 6 divided by 2. So I get 120 divided by 2. I get 60 meters. But if I add all this up, I get 190 meters. 190 meters. Okay, so that is the way to do it as a area under the graph, okay? And I think that's in the notes that I showed you. That is one way of doing it. I'm going to erase this now and doing kind of the graph, so the formula way. So if I do it the formula way, I'm going to break this into 3 different parts. Every single time the graph changes, I'm going to, so I have part 1, part 2, part 3. Now, I have a constant velocity here, okay? And I'm not even going to show you, technically you could use DTV. I don't even want to use DTV. I'm just going to use this formula every single time, okay? To actually figure out the actual distance in these 3 parts, okay? So every time the actual graph changes, you need to break it into those 3 parts. So let's do this part. Okay, I'm going to go VI plus VF divided by 2 and then multiply by the time. So what's my VI? 4. What's my VF? Still 4. So basically, I go distance equals 4 plus 4 divided by 2. How much time did it go? It went 20 seconds. Okay, so I get 8 divided by 2, which gives me 4. 4 times 20 gives me 80 meters. So part 1, 80 meters. If I look in this part 2, so if I look just in this part, okay, now I'm actually increasing my speed. Okay, so VI is 4, VF is 6, divided by 2, and then it went for 10 seconds. So it's going like this, 4 plus 6 divided by 2, multiplied by 10. So 4 plus 6 is 10, divided by 2 is 5, 5 times 10, 5 times 10 is 50. So in part 2, it went 50 meters. Lastly, part 3, started at 6 meters per second velocity, went all the way down to 0. So I'm going to go 6 plus 0 divided by 2. And then how much time did it take? Went from 30 to 50. Took 20 seconds. So 6 plus 0 is 6. Divided by 2 is 3. 3 times 20 is 60. 60 meters. If I add all these up, if I add 80 to 50, that's 130. 60, I still get my same 190 meters. Okay? So there's the two ways of finding the distance off of a velocity time graph. You can either do the chunk into shapes and find the area under the graph, or you can do the formula way. Either way works, both exactly the same. I would say most students more go the formula way, but it doesn't matter to me. All right? So there's part A. That's the longest part of this question. After this, it gets a little faster. So B, describe the motion of the object between 0 and 20. We have constant velocity. Okay? Our velocity is not changing, so it's constant. It's exactly the same. When the object is moving in the positive direction. So when is it moving in the positive direction? Okay, we have here it's accelerating. It's technically still moving positively here. There's still motion. It's not like the distance where there's no motion here. Still positive motion. We have acceleration, and then we have deceleration. It's moving negatively here. So when is it moving negatively? It's moving negatively here. All right, slowing down. What is the acceleration of the object between 20 and 30? So what is the acceleration here? Again, we have a change in velocity. So what's my acceleration? All right, so I'm going to kind of get rid of this now. I'm going to talk about acceleration with my red marker here. So to find acceleration, we're going to use this formula. Acceleration equals VF minus VI over time. So what's my acceleration here? My VF is 6 minus 4 over how much time did it take? It took 10 seconds. So I get 2, should put 10 in there. 2 divided by 10 gives me 0. I don't know where I have it written down here. 0.2. That will make sense actually. Meters per second squared. Okay, so that's the acceleration for that one right there. What is the acceleration of the object for 30 to 50 seconds? Okay. Well, again, I have to go VF minus VI. So 0 minus 6 over 20 seconds. Which gives me negative 6 over 20, which makes sense. It is slowing down. Okay, and that gives me an acceleration of, when I fill my page and find my answer, 0.3. 0.3 meters per second squared, and it's negative. Negative 0.3 meters per second squared. All right, so it says, what is the average acceleration over the 50 seconds? So what is the average acceleration over the whole 50 seconds? Well, did we have an acceleration? Yeah, we changed our speed over this. So I started at 4, I ended at 0 over 50 seconds. So for E, for the whole thing, I went up. Started at 4, went to 0. My bad, other way around. It should be 0 minus 4, VF minus VI. 0 minus 4 over 50 seconds, which means negative 4 over 50 seconds. And that gives me a very, very tiny negative 0.08 meters per second squared. And then it says, what is the average speed of the object over 50 seconds? The nice thing is we have the distance. If we didn't have the distance, this would be a lot more annoying. But you guys found the distance at the very start from question A. If you want to find average velocity, this is where our DTV. So the only time you can use this formula is if you're trying to find average velocity. The nice thing here, we are trying to find average velocity. We figured out the distance in the first part, and we have the time. So this can kind of be nice and easy. Just go distance divided by time. So my full distance was 190 meters divided by 50 seconds. My average velocity is 3.8 meters per second. So that is for your last question, G, okay? To find what is the average speed of the whole thing. Okay, so there's question 6. let's go to question 7 kind of quickly because that one's actually not too bad. There's not a whole lot of crazy stuff that we have to do. And then we'll be hopefully good for our velocity time graph. All right, let's go on to question 7. There we go. Let's get this out of the way. All right. Okay, get question 8 out of the way. There we go. Question 7. So it says, when is the object at the greatest? When is the velocity of the object the greatest? So when is the velocity greatest? There's no calculations like this. Basically, when does it get to the highest velocity? At 10 seconds, it holds all the way to 20. So you can say at 10 or from 10 to 20. Basically, either one's fine. But there's my highest velocity. So that's pretty easy for 8. When is the acceleration of the object the greatest? So the most positive. So here is where we have to calculate our acceleration. Now, again, you can probably tell right away when's my greatest acceleration. That's like basically that's my slope here. Acceleration is the change of velocity. Where does it look like the graph is changing the most? Looks like it's changing the most right here. Okay, but to find the actual like calculated acceleration, again, I'm going to go VF minus VI over T. So I went from 0 to 30, so 30 minus 0 over 10 seconds. G equals 30 over 10, or 3 meters per second squared. Okay? Here, again, these are and it says positive too. So there's only actually one positive acceleration, so that's that right there. When is the acceleration of the object 0? So when do we have a constant velocity? So when do we have a constant velocity? Right there we have a constant velocity, and right here we have a constant velocity. So 2 parts will have constant velocities, or acceleration of 0. Okay? When is the object slowing down? So it's not asking you to calculate it, but when is the object actually slowing down? Okay, right here it's slowing down in this 20 to 30 seconds, and then from 40 to 50 seconds, it's also slowing down as well. Okay? So that's where you have our slowing down. Our last thing, which is again the annoying part, what is the displacement over the 50 seconds? Okay, so this is where you could use one of your actual 2 ways to get it. So either you're going to do you're going to break this up into these. So you break it up into shape. There's another shape. Okay, break this up into a triangle and a box. You have another box right here. So there's your 3 shapes or 4 shapes you kind of have there. And you could do the area under, or you could do the actual formula way. I'm going to give you the final answer basically. So in the end, okay, it says what is the displacement over the 50 seconds? In the end, I think you should have basically 1,000 meters. Okay, so when you put it all together, you should have 1,000 meters. Okay, so I would have, and I did break it into all these parts here. So I found I just did this basically. Okay, the VI plus VF divided by 2 multiplied by time. So 0 plus 30 divided by 2 times my 10 seconds. 30 plus 30 divided by 2. And so keep going. In the end, you should get 1,000 meters. If you want to break down to this, let me know individually, and I can break this down. We can talk in person, or we can do a nice little video call and kind of go over it. But there's our velocity versus time graph. Hopefully everything went really well. And yeah, I will talk with you guys on Wednesday quickly. All right, 1 second. That's not what I want. I want this. All right, have a great day, class. Thanks.